For my problem, I chose to do Chapter 5, Problem 8, which says, there is a clever kitchen gadget for drying lettuce leaves after you wash them. It consists of a cylindrical container mounted so that it can be rotated about its axis by turning a hand crank. The outer wall of the cylinder is perforated with small holes. You put the wet leaves in the container and turn the crank to spin off the water. The radius of the cylinder is 12 centimeters. When the cylinder is rotating at 2 revolutions per second, what is the magnitude of the centripetal acceleration at the outer wall? So to begin this problem, I started by labeling my givens and my finds. So we're given that the radius of the cylinder is 12 centimeters and that the angular speed is 2 revolutions per second. Also from the problem, we know that we need to solve for acceleration, which is centripetal acceleration in radians per second. Then I labeled some of the equations we were going to need. So acceleration is equal to velocity squared over radius, and we also know that velocity is equal to radius times angular speed, which was labeled above as W. When you do some algebra on that equation, you end up solving for the equation that acceleration is equal to radius times angular speed squared. I then started by plugging those numbers into the equations, but before even that, we had to do some qualitative analysis to get centimeters to meters and revolutions per second into radians per second. So to get centimeters to meters, I just divided by 100 as shown here, and you get 0.12 meters, or is equal to 12 centimeters. Then after that, I went from revolutions per second to radians per second radians per revolution to get to radians per second, and I ended up with 157.9 radians per second. Lastly, I plugged it into the acceleration equation we found above and did 0.12 meters times 157.9 radians per second, which ended up with 18.94 radians per second. I then rounded up to 19 because, as shown in the problem, we start with 12 centimeters and 2.0 revolutions per second, showing that our significant figures will be 2. And so the answer will be the centripetal acceleration at the outer wall is 19 radians per second.